Alrighty, now let's just look at some more vertical shifts. I mean, we've basically already looked at this. Vertical shifts down. Let's just make d even more negative. So let's start with the x squared. If we make d equal to, say, -10, well, guess what? It's going to shift down -10 units. Let's do cosecant. Heck, we haven't done that in a long time. If we make d negative, every single one of those shapes is going to shift down from the parent purple function. It's really that simple. And again, I love how simple it looks. If p of x is the parent graph, I like to make it purple because that's what it is in the little applet. And f of x is the transform graph. And suppose f of x equals p of x minus d. It follows that p of x minus d equals f of x. And therefore, the y values of p of x are shifted down d units in order to reach the y values of f of x. Again, while keeping the same x values, as you can see here. For example, these are all the same x values, just the y values were shifted down. Here is our generic p of x chart. -2, -1, 0, 1, 2 with these p y values. We're going to keep the same x values. We're going to take those p values and subtract d, and it's just going to remain that way because it's very generic, and that will be our f of x values. Those will be our f of x values, I should say. So when f of x equals p of x minus d, this is what our chart is going to look like. Alright, lastly, when f of x equals p of x minus d, then the parent graph p of x will shift vertically, will vertically shift down to reach a transform graph f of x while keeping the same x values. That's going to be it for vertical shifting down. Next up, we're going to start graphing graphing transform functions using A, B, C, and D, using vertical shifts, stretches, using horizontal shifts and stretches and flips, and doing all those things put together. Okay, so we want to get a strong foundation. That's why I explained all these to you. That's it for this video. If you have any other questions about it, let me know.